It is 2 hours UTC on the 23rd of June 2018. Hey, everybody. Hope everybody's doing well out there. Come on in. Come on in. Welcome to the regulars. Welcome to the newcomers. Howdy to those who are watching this in the future. I hope the future is okay. You never know about the future. So who knows? Who knows? But yeah, so hope everybody's doing well out there today. So gather around, gather around. This is a circle of friends. It's just I'm just the host. I'm not necessarily the only one with thoughts and ideas. This is just my way of thinking out loud for a while, and you know, turning off the TV, forgetting about the news, just forgetting about almost everything else, and just focus on one thing, that being the science of astronomy. Hello, Totterbert and Atta and Bobby. Nice to see you in the chat. So yeah, don't consider this my necessarily my soapbox or anything. I'm as bewildered as everyone else is. So and just having fun, trying to understand, trying to figure out, um, and I think we go we are destined to go down lots of blind alleys, just thinking that we're on to something, and look, it matches the observations, and we can and all of that, and turns out to be dead ends. And so then you got to go back through all of that, and that's just painful. So yeah, gather around, friends, and grab your uh, favorite consumable. And tonight it is once again hydrogen hydroxide, so HOH. Yeah, I got a nice full mug here. Yeah, big full mug. So cheers. Hey there, Tom. Totterbert, I have yet to watch your videos. I watched uh, I watched a couple of them, and then I don't know. It's been a few days, and it's been a wild few days. Fun, but just a little crazy. Just a little crazy. Um, yeah, yeah. Yeah. Well, uh, you never know. You never know. But yeah, I can pretty much guarantee, because I brew this myself. I brew this myself. This is hydrogen hydroxide, HOH, for sure. Brew it myself. This is hot out of the tap. Hey there, Space TV. Nice to see you in the chat. Thanks for dropping in. Hope everything's well over there. Yeah, you're up. You're up at a crazy time of day, time of night. Pretty crazy. Is the sun up yet? Is the sun up in England yet? It's what is it, like 3:05 a.m., or are you in twilight? You must be near twilight. You must be, Space TV. All right, well, cool. Well, I hope everybody's doing well out there in the universe and the rest of the world. Things are Okay, here, yeah, just just busy at work. So yeah, just the just the usual busyness. So okay, yeah, okay. So sunrise isn't another 2 hours, but it's really light. Yeah, I mean it's twilight, right? The sun is coming up. I mean, I'm exaggerating, but the sun is coming up at a very shallow angle, right? So I mean, it's doing this, right? So um, this vector, right, perpendicular to the surface of the Earth, right, is moving up very slowly. So you get these really slow sunrises, really super slow. Yeah, yeah, white nights, white nights. I want to. What I want to do is I want to stand on one of the two poles at um, the equinox, either one, because at that point the sun will go all the way around, just skimming the horizon. It's like you have a 24-hour sunset or sunrise, whatever you want to call it. It's the same thing. I'd like to see that. I'd like to see that. I guess I would like to see a midnight sun, but not quite as much as I want to see that sunrise for 24 hours. I think that'd be very cool. Very cool. So okay, yeah, yeah, but it's a very slow sunrise. Yeah, so I'm not surprised that it's pretty light outside already there. Exactly, like living on a flat Earth. Exactly. All right, I so I actually listened to the latest music from the Hearts of Space last Sunday. I recorded it and pretty much immediately listened to it, and that was a pretty good one. That was a pretty good one. I um, yeah, that was all right. Oh man, I'm trying to. It was Indian music, yeah. Um, pretty cool stuff. Pretty cool stuff. So hopefully you didn't miss that one. Because yeah, that was one of the better ones. It definitely isn't like top 10 or even top 20, but it's one of the better shows that they've recently put out. So if you don't know what I'm talking about this this radio show. It's called Music from the Hearts of Space, and it's a weekly, uh, what was a radio show that came on, um, sort of like the local PBS radio stations, and it would be this ambient space music, really, like lots of reverb, or lots of delay, a lot of uh, a lot of really spacey sounding stuff. And if you like that kind of sound, which I do, um, you can listen to every single week on Sundays. On Sundays, the weekly show is free all day long, so you can listen to it. What I do, and it's probably against all the rules, but I'm doing this for myself. I'm not trying to sell it or even listen to it with anybody else. I just throw it on the computer and I listen to it over the headphones, and that's it. And that's it. So, but what I do is, yeah, I record it and then I listen to it later. So that makes it a lot more convenient And this time it was pretty much immediately after the live stream that I pulled that out and took a listen, and yeah, definitely one of the better ones, right? So here we can sort of look at the Music from the Hearts of Space website here. Let's see. So I think it's HOS.com. Pretty sure. Hide that away. See if we can get some action here. Well, Tom, yeah, I mean, technically speaking, I probably can't, but you get the idea. All right, here it is. It's coming up really slowly. Sorry about that. But here it is, HOS.com. They always have some kind of interesting graphical overlay. It's coming up a little slowly, but okay. So this week's program, we can go to this week. We can see that it's oh, they haven't changed it yet. So this is sort of the current week, right? It's called Beyond the Rugosphere. Slow and gentle, the harmonic drone and the ancient Bansuri flute invite us to another journey into the contemplative music of India. Yeah, it was a pretty good show. It was a pretty good show. I recommend it highly. I don't think I recognize any of these artists at all. No, I don't recognize those names whatsoever. So yeah, but I sure liked it. Sure liked it. Anyway, so if you like that kind of stuff, sort of I mean, they do a lot of ethnic music, which is usually pretty interesting too. But I really like the spacey stuff the most. But this isn't bad. This isn't bad at all. Can't complain about it. So yeah, if you're so inclined, check them out, and check them out on Sunday because you can listen. I think you have to sign up. I don't think that you can listen to it as a guest. So you would have to sign up for an account, but it's free, right? You have to have an account. It doesn't cost you anything, just some time. Um, so yeah, you can decide at that point if that's a good enough deal or not. Um, but yeah, it was a good one. It was one of the better ones for sure. But yeah, we'll have to wait until Sunday to find out what the next one is. And you know what? That's not exactly true. Music from the Hearts of Space tweets. Stop sharing. So they tweet. You just have to look for Music from the Hearts of Space on Twitter and follow them, and you'll get all the messages. And the new shows always come out on Saturday. At least it's announced on Saturday. I don't know if it's actually there on Saturday or if it's there on Sunday. I don't know. It's usually always there by Saturday. I know that for sure. So yeah, check them out if you like that kind of sound. I definitely do, and enjoy it as often as I possibly can. I mean, I record it and I listen to it later, and I usually thoroughly enjoy them. sometimes there's some pretty bad bombs, but for the most part, I think they do a pretty good job. Yep, pretty good job putting together a nice, almost always exactly an hour long show. I don't know how they do that. Um, well, they do have a little bit of flexibility when it comes to the introduction, right? So that's probably where they use that fill, right? Is they figure out how many songs are they going to go through in a show, and then they can figure out from there uh, uh, how long uh, sort of his monologue Am I back? Did I miss anything? I think I'm back. Yeah? Yes? No? Maybe so? Cheers? Yay! Well, sorry about that. The uh, the laptop says that it overheated, so it just shut itself off. And but now I've got a fan. Well, I've got a fan blowing on it in the back there, and I can, yeah, I can feel some air moving underneath. It was just really, really hot. Yeah. Yeah, working the machine pretty hard. Yeah. Yeah. So, yeah, tomorrow I will order my new camera. So, thank you everyone for that. I think I'm hoping that it'll be a little bit better. I don't know. I'm not quite sure which one I'm going to get yet, but it's probably going to be a Logitech. Um, so yeah, you know what? It probably is Uncle Bill. Yeah, Uncle Bill, you're right on. So yeah, if we open this, we would probably see more cat hair than circuitry. So so cheers. Oh, good. I'm glad I got back on. I was gonna say it's like, well, you know, this might just be a short live stream, but nope. Here we are. You're stuck with me for a little while longer. Too bad. Too bad. So I don't know. What should it be? Where should we go? Where should we go? We can. I don't think that there was any new news from the Hayabusa spacecraft going towards that asteroid. I think I looked this afternoon and didn't see anything new there. So, but that's very very exciting. Yeah, they're they're moving 9 centimeters per second. So you know I pulled out my ruler here and I looked at how far 9 centimeters is. It's about it's about that long. So every second, the Hayabusa spacecraft is moving that far. So one, two, right? So can't do it. One, one, two. Yeah, I mean it's moving. You know, relative to us, it's moving pretty good. But we could definitely walk next to it. So yeah. Any news on exoplanet hunting? Haven't heard anything. I've been waiting to see what's going on with Tess, right? Because Tess is I thought it was where it was supposed to be. It took that test image. It was about like a month ago, wasn't it? Was it a month ago? Um, oh, the slide rule. The slide rule? Huh. Uncle Bill. You want some show and tell? All right. Well, I'm gonna have to go and get it. I'm gonna have to go and get it, and then I'll tell you my slide rule story. Okay. I might be like about a minute or so. So hold on, hold on. Yeah, the space TV, the Mars dust storms. I think that there's a correlation, and I've heard I've heard that there's a correlation between these dust storms and oppositions with the Earth. Um, they seem to, at least what I've heard, is that they are sort of coincidental. And this kind of thing has happened many times in the past. I dare say maybe even every time. Um, don't know about that, but every what is it? 20, 22 months, something like that. Is that right? There's an opposition. So yeah, it wouldn't be too hard to go back in the record and find that out. You could probably go pretty far back, right? 20, 30, 40 years or so, and see if there's a correlation there. But yeah, it's we'll see if opportunity makes it through that or not. Uh, I definitely cannot be sad about that kind of loss. Um, that little rover has gone above and beyond, right? And has outlived, uh, I would I would say, probably most expectations, right? And has done very well. So if it's gone, it's gone. I mean, we'll get to it. We'll get, we'll get it. So I mean, it's only temporarily gone. Somebody will pick it up, and it'll probably go into some kind of museum or something, and that'll be that, right? So yeah, here's the slide rule. And there's a little booklet here. Can you see what that says? Probably not. It says copyright 1950. So yeah, so here it is. All right, so here it is. It's in this case. It's probably leather. All right, so there it is. There's the Sliderule. Is that pretty in focus? All right, well, cool. So there's the slide rule. There's the famous slide rule. So here's my slide rule story. Let's see. I'm catching up on the chat now. So Space TV, no, Hayabusa has not reached it. It's within 100 kilometers though, but it's moving at 9 centimeters a second. So you can do the math. I don't know if it's going to. It's probably unlikely that it's going to be changing that velocity. So you can figure that out, right? In fact, let's do it. Let's do it. Share my screen. And we're going to pull up the calculator. Okay, is that all right? Can everybody see that all right? So it's 100 kilometers, but it's 9 centimeters per second. So let's convert 100 kilometers into centimeters, right? So 100 kilometers is 100,000 meters. Oh, so there's 100 kilometer, or 100. There's 100,000. So that's 100,000 meters. And then there's 100 centimeters in a meter. So I got to add 2 more zeros. So what is that? That's 10 million. So 10 million centimeters is in 100 kilometers. And if it's moving at 9 centimeters per second, then what we're going to have to do is we're going to have to divide this by 9. Right? Divide it by 9. And that's how many seconds it's going to take to get there. So let's put that into something a little bit more reasonable, like hours. So there's 3,600 seconds in an hour. So we can divide that by 3,600. So that's how many hours, 308 hours. There's 24 hours in a day. So let's just look and see. So 12.86 days. So that's 12 days and then 0.86 of a day. So let's subtract 12 and multiply that by 24 to get the number of hours. So 12 days, 20 hours. So 12, 20, I'm going to write this down on the chat here. 12, 20. So 12 days, 20 hours. Then minus 20 to get rid of that. That's how many fractions of an hour are left. So that's times 60. 38 minutes. And we can subtract 38 and then multiply by 60 seconds. 31 seconds. So at moving at 9 centimeters a second, it'll take you 12 days, 20 hours, 38 minutes, 31 seconds to traverse 100 kilometers. So it's got a little less than 2 weeks before it actually makes its touch. Okay, so the slide rule story. Is here, let me stop sharing my screen. There we go. Okay, so this is when I was in the 8th grade. Oh, look at that, I'm tilted. Or is that you tilted? So in the 8th grade, had a very, very strict teacher, very, very good teacher, just pretty pretty strict and pretty rough in terms of the workload. It was enormous. Usually 3 or 4 hours every single night of homework, which, I understand homework, but that was an unusually large amount of homework. When I got to high school, it's like, man, I only have to do this for an hour. So, yeah, one of the rules was no calculators. Now, calculators back then, this was 1982, 1983. Um, Calculators back then were sort of the new thing, right? Uh, you were definitely somebody if you had a calculator, right? Um, and it caught on really, really quickly that at least the theory is that calculators made doing math easier. And I'm here to tell you that calculators do not make math easier. It makes math quicker, but it doesn't make it any easier. On the contrary, you're probably going to learn less, right? Uh, so anyway, so the rule was, right, because everybody was bringing in their calculators and wanting to to use them on the math tests, which then, even then, right, were numerical calculations, right, that one could very easily do on a calculator. And you know as I said, that kind of thing doesn't uh, help you with math. It just makes things go a little faster. So anyway, calculators were banned. Calculators were banned. So it's like, okay, I uh, and I don't know why I think of certain things, but some things just sort of pop into my head, and it's like I'm going to do that. So for some reason, somehow, I got it into my head that it's like, this isn't a calculator, is it? I mean, I knew enough about how to use it that it definitely does help me calculate. But using a slide rule is really hard. It's really hard. You have to be able to know how to um, estimate. You have to keep the most important thing with a slide rule is that you have to keep track of your decimal point, and it's really hard uh, to do that if you have like a long calculation, right? Because these slide rules, and I mean, I don't know everything about these at all. I cannot use much of the functionality on this at all. I can do multiply and divide, um, and I don't really even know if I remember how to do divide. Um, but yeah, there's I think there are cosine functions on here. There's definitely trigonometric. They've got the labels right on. So you use A and B when you're multiplying and dividing. That's the scale that you use. Whoa, we're sideways again. Sorry. Sorry if that makes you queasy. Now I got to focus. Maybe this new camera will autofocus and drive everybody insane in a different way. So I said, okay, I'm going to bring this
slide rule in, you know, being sort of a smart aleck, right? Trying to outsmart the teacher, right? That's what you know, 12 or 13-year-old kids do, I guess. You know, they think that they're pretty hot shit, and it's like, okay, I'm gonna see how this works. He won't take this away. He won't. It's too valuable, right? And I mean, he's going to recognize that. So so yeah, I brought it to school, and I when it came to math class, I pulled this out and put it on my desk. I just, you know, pulled it out of the case, put the case away, just plop this right on the desk, like that. And I don't know when he saw it, but I remember that I was using it. Right, I was doing some kind of multiplication or something, right, and I could see him coming up from behind me. Right, he was like, sorry, he was like pacing the aisles between the desks, right, in and out, in and out, in and out. And when it came to my row on my right, he was coming up from behind me, and so he saw what I was doing, and called me up to his desk, right, which was in the front of the room, um, and you know, he said, "Bring that too," you know, pointing to this, and it's like, oh man, he's gonna take that away. That mofo, he's gonna take away my slide rule. Um, so, but I got up there, and uh, he's he asked me if I knew what this was, and it's like, yeah, it's a slide rule. And he says, well, do you know how to use it? And I said, well, a little bit. A little bit. I can multiply and divide on it. I can't understand why I can't add and subtract. I mean, it seems to me that adding and subtracting would be easier than multiplying and dividing. This was before I had any concept of logarithmic scales. So there's a good reason why you can't add and subtract on a slide rule is because that adding and subtracting is linear. It isn't, and so it can only follow the linear rules, and there's no way to encode those rules on a slide rule. A slide rule, as I said, I think fundamentally deals with logarithmic scales. Um, yeah. So so I told them, you know, that I knew how to multiply and divide. So he, right there, he said something like 2,389 times 586. And so, you know, meaning that he wanted me to do that. He wanted me, you know, to multiply it out uh, on here. And we're using this, right? And so, you know, I'm like, okay, okay. And so I did it, and um, I think you know, he worked it out, you know, the usual way, you know, up on the chalkboard, um, and I think our numbers matched. Pretty sure our numbers matched. So yeah, he liked the idea that I sort of understood how these worked, and he pointed out later that um, knowing how to use a slide rule actually gives you a better understanding uh, of what you're doing than, you know, memorizing or using a calculator. So you learn the most. You learn the most with this. So you know, I've always been into totally learning the most that I can. So yeah, I definitely like my slide rules. Now, the only downside to this whole story right? So okay, nobody else is allowed. Uh, well, no, he changed the rule. He said, slide rules uh, um, are allowed, and of course, I was the only one in the class that had a slide rule. I was the only one in the class that even knew what a slide rule was. So, so yeah, the only downside is that I was not liked. I was not liked for oh probably at least a couple weeks because nobody understood what these were. So everybody thought that I was getting away with murder, right? That I was able to cheat, and no, it's the opposite. It's the opposite. You have to know more in order to work these things. So yeah, yeah, instant outcast. Yeah, yeah. Well, never, never really a joiner of any sorts anyway, Uncle Bill. So cheers. Yeah, I am Patrick. I'm very perplexed and confused about why Report of the Week is as popular as it is. I'm not quite sure. I'm not quite sure. I mean, I I think it's really really great that it seems as though this guy is pretty smart, right? Is pretty smart, um, very respectful, and um, very well, not necessarily incredibly articulate, but more much more than I am for sure. Yeah, he can get his point across, and yeah, yeah. So, but I don't understand, and that's just because I'm too old, I guess, way too old to understand these kinds of things. Um, but I'm not quite sure why that channel is as popular as it is. I'm not quite sure what the draw is. Maybe it's just that it's a little odd. I don't know. I mean, I don't necessarily find it odd. Um, yeah, I don't know. I don't know what the draw is. The kind of slide rule that I want to get is actually one of those round ones. Have you ever seen those round ones? Yeah, I want to get one of those and learn how to use it. I should really learn a little bit more um, about how these are used because you know what, you know what, honestly, honestly, um, I could definitely use this for the kind of simple calculations that we're doing here. I could definitely use this. Yeah. You know what? Maybe I should. Maybe I don't have to get another calculator. Maybe I can do everything on here. Well, I can't add and subtract. So I would have to add and subtract on a calculator on this laptop. Hmm. So that's the only drawback. It's the only drawback, I guess. Yeah, Atta, that's sort of my sentiment too. I'm not. I mean, as I said, he seems quite intelligent, and really, and maybe this is it. Maybe this is it. I can tell. I can tell that he is really, really having a good time with this, right? Whether he's acting or whether he's, being himself, I don't know. And it doesn't really matter. But I think that's maybe part of the attraction is that he really does seem to be enjoying himself, right? Um, so yeah, yeah, he is sarcastic.
as I said, I mean, he's a pretty smart dude. So yeah, he's got lots packed into that brain. I would, I thought I heard him say that he only eats like one meal a day, which which is fine. But if it's that one meal that he's eating right there, it's like whoa, you need yeah, just don't do that every day. Yeah, you're not going to be around to make any more of these interesting videos. His radio show, his shortwave radio show, is has two parts to it. One part is him talking, and the other part is him playing music. And he talks about the music, or if he gets some kind of comment, he'll bring up the the comment. Um, uh, but yeah, I'm not quite sure what the appeal is. What the appeal? Not quite sure. Not quite sure. Let's do a quick. Uh, let's do another object of the day. Uh, Yesterday was sort of, um, way above and beyond the call. We're looking for. I mean, not to bias selections or anything like that, these random selections or anything, but I guess I can bias it a little bit. Don't necessarily want to examine the more popular um, targets. I want to look at things that don't get a lot of examination, um, and sort of wonder why. What's you know why study that and not that, right? I mean, there are probably very good reasons why some objects just aren't studied all that much. um, but yeah, I don't know. I would think that everything would have some some value to it. Anyway, so let's do that. Let's do another object of the day. So I'm gonna share my screen here. Come on. I'm also Uncle Bill. I am thoroughly, totally enjoying Doctor Who on Twitch. They're now up to the fourth Doctor. Now the fourth Doctor, of course, is Tom Baker, and he's probably the most popular one. But my favorite Doctor is number 3. I thought that um, what's his name, the actor, um, and Doctor Who as a character uh, was really, really awesome. The third, John Pertwee. John Pertwee. Um, awesome actor. Um, I like that Doctor the most, number 3. But yes, I'm thoroughly enjoying uh, being able to finish this live stream, right? Finish it in a little while here, a few more minutes. Um, and then go into the living room and turn on some old Doctor Who, and have sort of a late dinner, and watch a good hour or so worth of Doctor Who, and then end the day, right? Very, very awesome. The only thing that bothers me, Uncle Bill, about that Twitch stream is, and I don't know if you've been watching it or not, but those segments in between the um, uh, each show, right, where they have like little uh, cutouts from various of the Doctor Who shows.
right? And they stitch them all together into this long thing. Well, they usually repeat that at least twice and oftentimes 3 times in a row, right? So it's like seeing the same like 3-minute commercial 3 times. And by the third time, I'm going insane. All right. Well, there are 7,840 NGC objects, New General Catalog objects. Most of these are not stars. So they could be galaxies, open clusters, globular clusters, gaseous nebulae, or planetary nebulae. And some of them are stars. They're misidentified stars as being, like a galaxy or something. But for the most part, these are non-stellar objects. So let's have random.org choose an integer between 1 and 7840 and see what the object of the day is going to be today. And I won't get distracted with HST. We should look at HST, but I'm not going to get too distracted. So 4894. So let's go over to HST. Oh, wrong archive. What did I say it was? 4894. Okay, NGC 4894. Now that seems to me to be near or in the Virgo cluster. Either the Virgo cluster or the Coma cluster. So it's probably a galaxy if they observed it. Oh, they did. Oh, 4898. 4889. Why is it I'm not quite sure why it would do that. Let's sort these by date. And I promise I'm not going to linger here. I just want to look. Wow, there's a lot of galaxies there. Oh, that's it. That's the field of view. Not bad. Let's look at this one. 2010. Ooh, overexposed galaxy. Wow. Now, are there 3 colors? There's only 2 colors. Only 2 colors. Yeah, I don't know what these differences are, but yeah, there's only 2 colors. Oh, that's too bad. Oh, it's over here. Wow, that's pretty spectacular. Look at all those little galaxies in there. There's a big one. Wow, look at them all. Little spiral galaxy here, probably very far away. Look at these spirals way back here. Look at that, they go all the way back. Holy moly. That's a lot of stars. Wow. Pretty too. Very pretty. Dang. So tempted. I'm so tempted. So this is 475 and 814. Why did they do such a short exposure here? Oh, I see. That's a different thing. Okay, I gotcha. Okay, so they did 841 and 475. Oh man, should we grab this? Put it up on GIMP. Just plain old stains. Okay, so let's save this one. I don't remember which one it is, but I'm just going to call it. What was this? 4898? NGC 4898.001 JPEG. And let's grab the other one. So that was the 814. So that's red. Let's make that one red. So number one is going to be red, and this one's going to be blue or some other color. NGC 002. That. So now let's go over to GIMP. I'm going to make this really quick because I want to find out a little bit more about this this object. HST is fine, but it's so easy to get buried. While that's going on, I can go over to Simbad because GIMP takes a little while to load. This poor machine is having to work so hard. NGC 4894. NGC 4894. Before. So yeah, definitely a little galaxy for sure. So there are the celestial coordinates. That's right ascension, right, which is 13 hours, 0 minutes, 16 seconds. And then a declination of positive 27 degrees, 58 minutes, 3.1 seconds. And Uncle Bill ID'd it all already. It's an S0 galaxy. So they do classify it as a spiral, but they don't see any arms. So that's why it's a 0. So they don't see any spiral arms, but they're calling it a spiral. Probably, looking at the picture over here, it's probably because it looks like it's almost edge on. So, elliptical galaxies don't have this really, really long axis, right? They're more spheroids, right? They're egg shaped. Um, yeah, appreciate that, Uncle Bill. Post away, post away. So pretty faint, but wow, it's been observed with many different filters. This is wow. This is pretty much all the filters, all the scientific filters that are available to astronomers. UBV, R, and I, G, J, H, and K. So this is going from short wavelength, almost ultraviolet, and that's why it's called U, through the blue, through the V, which is visible, red, getting into the infrared, and then G, J, H, and K are definitely into the infrared. But then U, G, and R are sort of like U, U, B, and V, sort of. And then I and Z are also infrared. So these are just the brightnesses, and as you can see, it's brightest in the near infrared, right around like 12th magnitude here in K. So that's not too bad. So yeah, a little bit red, but that makes sense. So there's all of its other names. All of its other names. Usually these are just catalog names. There's even a Gaia data release 2 number. So there you go. 4894. It looks like this is sort of a well-known
a well-known object, 55 entries between, well, 1850 and 2018. So that's pretty cool. Let's see how far away it is. I'm going to try to use, I should try to use my slide rule, huh? Did we do this? Looks like GIMP is up. Let me see if I can load these galaxies up really quick. I hope, I hope that this is moderately enjoyable for everyone. This is just us going down sort of the same path, following the nose, as I say. And I'm put you down just for a sec. Okay, so there they are. They're going to load into 2 different layers. Okay, so there's that one, and there's that one. So there they are. So now what I'm going to do is I'm going to invert them. I'm going to change this to RGB. Got to do that first. Okay, then I'm going to invert them both. See, so you can't see this one because this is a layer on top, but I can make that top one invisible, and there it is. So, okay, we're going to invert that. I don't know why I did that. Okay, so now they're both the other way around. So now I'm going to come over here and I'm going to go screen, and this one is going to be screen. So that's essentially adding them up. So now number 1 we said was the red one. So let's make that red. And I think red is down here. And what do you say? Let's try red and green first, and then we can go to red and blue. We can the thing is, one of the points that I'm trying to make here is that we can make these colors anything we want. Any 2 colors that we choose, we can make these layers, right? So I'm arbitrarily choosing red, green, or blue, but we could choose any color, and there are 2 to the 24th choices for each color. So lots of choices, but there's the red and the green. So can we can move around here. Oh, we're moving the green one. That's not good. Okay, we don't want to do that. Okay, well, I'll just move it around this way. Let's merge these, and then I'm going to change the brightness and the contrast. And I promise I'm not going to stay on here very long. Yeah, that's not really helping much. Okay, well, let's try blue really quick, and then we'll stop this this messing around here. I just like to share different things with everybody.
Try to have a little bit of variety. So that looks pretty cool. That's not too bad, huh? I don't know if let's go back to here. Okay, so we've got the distance, right? That's 60.81 million parsecs. So parsec is 3.26 light years, and we're going to multiply that by 60, like 61. Let's see. So can I do this on my slide rule? Let's see. I'm going to take 60 and I'm going to multiply it by 3.26. And I want to say, oh man, I don't think I'm reading this right. Oh no, that's it. So I want to say it's 100, it's about 185 million light years. 6 times 3 is 18. Yeah. So about 185 million light years. And yeah, that's right. So what I did on the Sliderule is on the A line, I put my crosshair on 6, right? And I kept in mind that that's supposed to be 60, right? I'd like to make it 61. Right there's 61. Right there. Then I take 3.26. I put that on the B line and I line up the things. So there's 3.1, 3.2, 3.26. And then I read the answer on the 1 of the B line, and I get 187. 187 million light years away. Now, sorry that you couldn't hear that very well. So on my slide rule, I think I said 187 million. I can sort of cheat and say 61 times 3.26. Oh, it's 198.86. All right, well, I'm off a little bit there, no biggie. So about 200 million light years away. So that's pretty close, actually. That's pretty close. Looks like it's moving away from us at about 4,500 kilometers per second. That's moving. All right, let's see. Check this out. Now, this is the Sloan Digital Sky Survey image. So this is not the HST image, but we might be able to match these up if we can find a similar field of view. If we can find, some galaxies that look similar to that. So a flat one, a big round one, and an oval one, smaller. Let's see. Can we? Is it possible that we can find that one? Because there's lots of galaxies here, but I guess that's supposed to be the one right there, right? That's our NGC 4894, this guy right here. I'm just trying to figure out what this field of view is, because it's not 4894, right? It even said in the even said on the little HST thing. Oh, I erased it. But yeah, it was like 4889 or something like that. So yeah, I guess I'm not too sure. I don't necessarily see anything. It's hard to get a sense of scale here though too. So well, let's just move on. That's our little guy. And look, he's either in front of or behind this bigger one. Look, these stars of this one, right? These stars extend way out here. Do you see that? Way out here. So that's pretty awesome. Nice cluster of galaxies, of course. Um, no, Space TV. I'm looking at my live stream on my smartphone, and the orientation is exactly the same as I'm seeing it on my screen. Oh, do you think you got it? Up here somewhere? Yeah, I don't know. Our little guy is right there. So, yeah, I don't know what the scale is. That's part of the problem. I'm not quite sure how much of the HST is it is in this image, right? I mean, is it all of it? Is it, or is it just a little postage stamp? I'm not quite sure. So, yeah, I don't really see that pattern anywhere here, but I'd have to take some extra time to really take a look. So zoom in again at the bright star in the middle. Which one in the middle? Talking about that one. The thing is, though, I'm not seeing any stars in the HST image, right? This is probably a galaxy over here. Unless that's it. I don't know. It's got to be right in between those two blobs. And I don't remember seeing. Where's our guy? Our guy is down. Here's our little guy. Whoop. Yeah, right there. Yeah, I don't know. I don't know. That's a hard one. I'm not gonna spend too much time worrying about that because yeah, we're running long as usual. Hope everybody's enjoying as much as I am. Sorry, Space TV. Let's look at a few of these papers and then we'll get out of here. Let's see if there's anything necessarily interesting about NGC 4894. Where are compact groups in the local universe? Coma cluster, coma cluster, structure and assembly of massive galaxies in the center of the coma cluster. Yeah, they're absolutely huge. Ooh, S0 galaxies in the coma clusters. Environmental dependence of the S0 offset from the Tully-Fisher relation. Oh, well, let's see if 4894 is mentioned. Sometimes they are, sometimes they aren't. So we'll go into ADS here. And hopefully there's a link to archive. Yay. And there it is. So let's see, 4894. There it is. There it is. Do they even have a picture of it? GMP 2815. Yeah, there it is. There it is, right there. Cool. What do they say about it here? So yeah, they're just measuring the position in the sky, right? Position in the sky, the position angle. So that's the angle to north, from north, right? So this is probably north going up like that. So this angle here from here to here, they're saying is, they say 30 30 32 degrees. So it's got a G magnitude of 15.478. Very precise. Very precise there. Got an I magnitude of 14.469, a K magnitude of 11.88. I don't know what CZ. I have to look in the text to find out what's. It's some kind of a velocity. Maybe it's the yeah. It's probably the how it's moving in relation to our sun. That's probably what HEL means, heliocentric, probably. So that's probably how far away it's moving away, or how fast it's moving away from us. Yeah, but maybe that is. I don't know. Anyway, cool. They drew little lines and everything. So there's a lot of S0 galaxies there. Pretty cool. But there's our guy right there. Let's zoom in on him. Yay, little guy. There he is. GMP 2815. Yeah, very cool. I don't know what the red lines mean. Does it say? Okay, the orientation of the long slit. So they did a spectroscopy of this too, and the light that went into the spectrum that went into the spectrometer uh, went through this gap here. So that's sort of the area of the galaxy. So obviously they're sampling sort of these long axes here. That's pretty cool. All right. Well, look, it's late. Let's call it a live stream, and just go back and relax into either the day or relax into the evening here. All right. So take care, everybody. Hope everybody does well the next evening, the next day, whichever it is for you, depending on where you are on this sphere of ours. All right. So take care, everybody. Hit the thumbs up if you so desire. Make some comments. Join my Discord server. All those links are down below. Down below. So, all right. Take care, everybody. I will see you on the spin in like 22 and a half hours. Yeah, only 22 and a half hours. And we'll be back doing more astronomy. All right. Take care, everybody. Peace and cheers.